Next speaker, Prof. Dr. Marwa Shalaby. Prof. Marwa Shalaby, full professor of chemical engineering and bioplant, Institute of Engineering Research, Energy and Renewable Energy at the National Research Center. Member of flagship group, Center of Excellence in the National Research Center. Also, she the main representative of the Egyptian Society for Membrane Technology and its application. Please, Dr. Marwa.
Good morning, ladies and gentlemen. It's nice to begin the second day of our conference, and it's my pleasure to be with you in my presentation. Firstly, thank you, Mr. Chairperson, for the presentation. My presentation entitled Effect of Graphene Oxide and ZnO Oxide Nanostructure on the Chlorine resistance TFC-RO membrane using PDA and Poly-Methacrylic acid. This study is coming from the project between the Egyptian group, Egyptian research team, and the German team headed by the PI, Professor Ralph Walton, and Engineer Christoph from Marwa Institute in Berlin. This work, we have here, we can have illustration that our presentation today will take care of how to protect our TFC membrane from the chlorine attack. Because you know that TFC containing the polyamide layer, and the polyamide layer is the key layer for the RO membrane. It is the active layer which is dealing with the high percentage rejection and also having the commercial RO membrane having a good percentage rejection and percentage permeate flux. So how to protect this TFC membrane or this polyamide layer while taking care of both key parameters? How to take care of getting the percentage rejection the same or not affected, also to protect not to lose the percent flux or the permeate flux and for the productivity of these membranes. In this slide, we will have a quick background for the situation for our water crisis in Egypt. Also, the current situation dealing with our RO membrane, which we have get some notice for it now, and the suggested solutions, some of our experimental work, the results and discussion, some later, and also our future perspectives. All of us know that we have in our country the water shortage, and we have a high need or required for the desalination, and also the shortage of of water in Egypt have been illustrated many times in yesterday's presentation. So we'll go to our own membrane desalination problems, and the main problems we are dealing, as we said before, the fouling problems and the chlorine attack, where the chlorine is very important, and all of them and both problems are getting some correlation with each other. Why correlation? Because we know that as we increase the presence of the biofoulants or the presence of the fouling agent, which is mainly coming from microorganisms, algae or something like this, so we need to increase the dosing for the chlorine. As you increase the dosing for the chlorine, you have many cases of some disturbance comes to the RO, which decreases its lifetime and increases the steps for the dechlorination, which increases the cost for the desalination plants. You have here have a look for the conjugation between the fouling and the presence of the chlorine exposure problems. All of us know that the presence of the chlorine with the polyamide causes the deterioration of the amine group. Some reactions and some hydrolysis occurs over the polyamide surface, which causes its destruction. In the solution which we shall suggest in this work is the presence of the graphene oxide. The graphene oxide is one of the structures which has an important role and plays an important role for these RO membranes. The presence of this graphene oxide can protect the polyamide layer by absorbing the chlorine radicals, the OCl radicals, which get some good chlorine resistance. So the question which we begin our study, how to deal with graphene oxide. All of us know that graphene oxide may present alone. All of us know that there is membranes existing graphene oxide only. But in our work here, we want to entrain the graphene oxide in the polymeric structure. So where to put the graphene? Put it in the blend, in the mixture of the polymeric structure of the matrix for the membrane. This is the first solution. The second, to present in the surface modification solution as a layer. By layer deposition, increase the layer for these membranes. So how to optimize, how to compromise, how to get a good solution to, as I said before, we have more than parameters to deal with. We have to deal with the percentage rejection. Also, we have to protect the productivity of these membranes. Also, from the suggested solution is the spacer geometry. Also, the spacer can protect, the spacer can have effect for the fouling and how to decrease the fouling for these membranes. In this work, also, we have to illustrate the effect of tannic acid and its hydrophilicity and its conjugation with the graphene oxide. The experimental work here, we are dealing with the presence of zinc oxide isolate, where we are giving some conflicts between the zinc oxide in presence of organic structure to get zinc oxide with glycerolate. Also, we have graphene oxide. And all of these were blended with the polymer structure to be studied without surface grafting, without surface treatment or surface modification, and compare it with the black one without blending with graphene oxide or zinc oxide, and getting surface modification or surface grafting using grafting with the Poly-Methacrylic acid. Also in this work, we have tried the effect of the polyvinyl alcohol with the glyceraldehyde and the layer by layer deposition to study the effect of more than one layer deposited over the surface of the membrane and the effect on the fouling and flux produced from these membranes. The prepared membranes were subjected to fully chemical characterization using the BET area, the scanning electron microscope, and also the mechanical strength for these membranes were studied. Also, the contact angle will be highlighted to show the effect of the presence of hydrophilic additives as tannic acid. Here we can have a look. We have here different formulations. We have more than 5 formulations to study the effect of the presence of graphene oxide and its absence, presence of tannic acid and its absence, presence of zinc oxide and presence of zinc oxide in the structure, and the absence of all of them to get the blank one with the polyvinyl only. Also, these types here we have made for them some treatments. The T structure, which is giving the blue line, is getting for the thin film composite. The TG means that we have 2 layers deposited over each other. We have the thin film composite and have a plastic layer of the Poly-Methacrylic acid. The P is the PBA deposition only with a glyceraldehyde. The PG stands for the presence of layer by layer deposition. We have 2 layers here, the PBA with glyceraldehyde, followed by the membrane to be followed by surface grafting by the methacrylic acid. All the grafting structure was made in presence of the graphene oxide over membranes which don't have graphene oxide. So we have many blends and many structures to highlight the effect of each one. Here we can have a look as a sample. This structure which is containing the tannic acid in the blend of the membrane, and having here the comparison between the thin film composite, the thin film composite after grafting, and here you can see the scanning electron microscope and its morphology. The morphology of the thin film composite is compact enough, and after getting the grafting, you get some spongy structure, some more structure, which means that it has some more bulge. Also, when we have a look here for PDA with the graphene has a battery effect on the scanning electron microscope. This is another one. I not have many things to say here. Yes, this one, which is the C or the third blind matrix for these membranes, it contains the presence of the graphene in the structure, the presence of graphene in the blind mixture of these membranes, and in this way you can see here the 3T, the structure of the top surface shows that some structure for the presence of the graphene in this in the structure of the membrane, but in the synthetic composite it's free of graphene. The synthetic composite is free, and for the TG it has graphene in the graphene layer for the methacrylic acid. Sorry, this layer for the PTG. You have here the graphene oxide in the graphene layer, and it has a good effect. Also, they are scanning, the AFM, the atomic force morphology microscopy for the structure shows some smoothing in the structure for the TG, where we have a thin composite with the graphene layer in presence of graphene oxide and the presence of the graphene oxide in the blend mixture. This means that we have graphene in two places. Future perspectives here, which we will work upon in the coming months, comparing the studies for these membranes upon treating it with plasma and Graphene with a continuous chemical-based surface modification unit, the production of RO spiral modules for continuous experimentation, and finally the techno-economic feasibility study for the studied scenarios. Before I finish my talk, I want to invite you all to join the Egyptian-German workshop, which will be held in the National Research Center on 21 September in the new hall. Hoping to see you. I want to acknowledge my group. Thank you for the cooperation.
Thank you, Professor Marwa, for your deep presentation. Only one question for the audience. Please, Dr. Rector.
Thank you, Dr. Marwa, for the very interesting work, very logical, once. I have a simple question. Very essentially, polyfinyl is the most important solid powder. So which means that I can keep certain level of chlorine in the seed of the membrane without damage of the membrane.
This is a very good question. Thank you for the question. Yes, we can do this, but in our study, because the new technique now, which is made in the desalination plants, not to keep the level of the chlorine dosing the same all the time, but they are using some chopped doses. Yeah. So the chopped doses, this is what we are intending to study in our work. Why chopped doses? This means that the membrane may have some place for these chopped doses to go to membrane. Unless we have many pre-chlorination and many steps, we have studied the increase for the chlorine concentration on these membranes. So we put these membranes on a situation for these chopped doses and showed the effect and their tendency to help the polyamide to protect it. And while we have these layers, we protect the polyamide.
These shock chlorination was not started by chlorination?
No. Yeah.
What about the stability?
This is under study because I thought that we have now the continuous experimentation because we will perform the final bond unit for these membranes and so complete the study for its stability and the stability of all the layers.
Thank you.
You're welcome.
Thank you, Dr. Marwa, again.